According to psychology, solving LeetCode is one of the most boring tasks that programmers can do. So I'm in a quest to make LeetCode fun by creating LeetCode variants. But before jumping to it, I first need to create a fully working LeetCode clone to start with. So I gave myself 48 hours to create my own LeetCode, but worse. I started by creating a React app and designing a basic replica of the problem page of LeetCode. Created an area where users can write code, and to enable syntax highlighting and different language supports, added an online ID into it. For the ID, I'm using the AC editor module, which provides a pretty neat solution to adding an online ID and also supports a lot of themes and languages. And with just one single tag, I had a whole online ID up and running, which looks pretty cool. Now the challenging part was to figure out how to compile and execute the code, which took like 50% of my time creating the platform. The video constraints were originally supposed to be 24 hours, but as I was unable to find a suitable way of implementing this, I had to extend it to 48 hours. So there are a few ways to compile code online in your website. One is to create your own backend API in which you have compilers for each language. You send your code into it and it returns back with the output to you. Well, this is easy to execute in your local host environment. Reason being, you can download the support for each programming language like G++, GCC, JDK or a Python compiler and add it to the path, and when you compile the code locally, it will work using the compilers you have specified. The problem was how to go about when you have to host this globally, because then I don't have a local environment to support the code execution. To go about this problem, there is another way, that is to use an online code compiling API. Using this, you just have to make an API call, pass in your code and get the output in return. I went for the second approach, but I searched like every API and could not find anything with a free plan. A whole day was spent just searching for a tool to get it up and running. Finally, giving up, I went for the first approach, thinking that I would figure out the hosting part later. To start with this, I created a backend server using Node.js in which I can send a post request that takes the language and code as parameters, creates a new folder, code, and in the side, it creates a new file, code file, and adds the passed on code to that file. I was facing some issues in simultaneously combining the code and running the output file for C++, so I just created an empty exe file beforehand to avoid any errors. Finally, after all the files are created and the code is added to the new created file, the path of the code file is sent back as response. Now using child process in Node.js and calling the exec function, we can execute this file using a similar command we use to execute any code file in the terminal. And after the file is executed through the terminal, the output is captured and sent back to us. The backend part was working as I wanted, but as soon as I coded all this, out of nowhere, I found this Piston API while watching a tutorial. This API basically solves all of my problems. It compiles all of the different languages, sends me an output, and is also free. So yeah, it's working finally for me. The good thing about this API is that it also returns the error and the correct index of the line in which the error is being committed. So this feature can be useful later. So now our online editor is completely working. In LeetCode, only the problem function is presented to the user, and rest all the code including the header files, the libraries used, the main function, and the code to check all the test cases, all of this is abstracted from the users. So I created a pre-code which would be added on top of the solution submitted by the user, creating a full and complete code file, which is then sent to the API to execute and to get an output out of it. I've also added the functionality that will check the answers of the submitted code against certain test cases and display which test case failed or passed. Finishing this, created a very simple looking problem page that will display a list of problems and their difficulty. Now the thing left to do is to add more problems to the platform. So for that, I just copy pasted the outer HTML code from the LeetCode website itself, which made it easier as each element that needed additional styling already had a tag around it, and these tags were standard for all the questions on LeetCode. So I was easily able to replicate the problem formatting using a single CSS file in no time. And this is how the problem looks, which is almost same as Leet. After that, I added all the problem format code, preprocessor code, test cases, and starting code that is given to the user in a separate file, and linked everything with the problems page by index to dynamically load the problem in the code I want according to the demand. Problem formatting was not working properly when loaded dynamically, as React takes every input in it as a string and not as an HTML code. We used a library named interweavex that provided a good solution to the problem, bringing back the formatting to the text. Finally created the test cases for all the problems, which are just 3 for now, as the previous one was bugging a little bit with the cursor. Finally added a console window that will display the output and show whether a certain test case is passed or not. And that was it for the video. All the resources are linked below in the description. I'll see you in the next video. Till then, goodbye.